Bismillahirrahmanirrahim. Dear students, welcome to the Electrical Engineering channel. In this lecture, I will describe you the analogy between the laws and theorems in electrostatics and electrodynamics. In electrostatics, we discussed Coulomb's law, and the similar law in electrodynamics is Biot-Savart's law. In electrostatics, we had Gauss's law, and in electrodynamics, we have Ampere's law. And Gauss's law is d dot ds closed surface integral equal to charge enclosed. And in Ampere's law, we have h dot dl closed line integral equal to the current enclosed. In electrostatics, the electric flux density is equal to epsilon times electric field intensity. And in electrodynamics, magnetic flux density is equal to mu times magnetic field intensity. In electrostatics, del dot d equal to rho v, or divergence of d is equal to volume charge density, and here we have curl of magnetic field intensity del cross H is equal to volume current density. In electrostatics, we had divergence theorem. In electrodynamics, we have Stokes theorem. So that is the brief analogy between laws, theorems, and quantities in electrostatics and electrodynamics, and hopefully you have understood this analogy. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.